Right, welcome to the A2 section of the definitions. This is going to cover mainly Chem 4 and Chem 5 and some of the AS synoptic definitions as well. The important thing with all definitions is that you spend time and just sit down and learn them, whether that means writing them out multiple times or just watching this video repeatedly. Either way, there will be a large number of marks during the two papers, Unit 4 and 5, that will come from just definitions. Right, so let's get started. Right, first of all, rate of reaction is the change in concentration per unit time. The rate equation shows the relationship between rate of reaction, concentration of reactants and the rate constant. Order of reaction is the sum of the powers in the rate equation. Activation energy is the minimum energy needed for a collision to result in a reaction. A reaction mechanism is a proposed sequence of steps by which a reaction proceeds, deduced from the rate equation. Rate determining step is the slowest step in a multi-step reaction and it dictates the overall rate of the reaction. Equilibrium constant is the concentration of products divided by reactants raised to the power of their stoichiometry. Le Chatelier's principle states that a system at equilibrium will respond to oppose any change imposed upon it, and a catalyst increases the rate of a reaction by providing an alternative route of lower EA, and it is not consumed during the reaction. A Bronsted-Lowry acid is a proton donor, and a Bronsted-Lowry base is a proton acceptor. pH is minus log H+. Kw is H plus multiplied by OH minus. Ka is H plus times A minus divided by HA. And pKa is equal to minus log of Ka. With all those definitions, it's important that square brackets are applied in the right places. Right, the end point is the point at which an indicator changes colour, indicating the end of a titration, and the equivalence point is where the H plus concentration is equal to the OH minus concentration, and this is usually around pH 7. Half equivalence is where 1/2 equivalence of the base has been added to the acid, and a buffer solution is a solution that resists change in pH upon addition of small amounts of acid, alkali or water. Right, an acidic buffer will maintain a pH below 7 and it's made of a weak acid and a salt of its conjugate base. A basic buffer will maintain a pH above 7 and this is made of a weak base and a salt of its conjugate acid. Stereoisomers have the same structural formula but the bonds are arranged differently in space. Chromatography is a technique for separating components of a mixture based on their affinities for a stationary and mobile phase. The two of those that you need in Unit 4 are TLC, thin layer chromatography, gas liquid chromatography, and there's also a small section on column chromatography, so there's actually 3 in total that you need to know. A chromatogram is a pattern of separated substances obtained by chromatography. This would be, for example, your chromatography paper or your chromatography plate after you'd carried out the process. That's what you call your chromatogram. Retention time is the time each component remains in the column. And the chromatograph are the apparatus used for doing chromatography and chromatographic separations. Right, we're now going to go on to the Chem 5 definitions. So the enthalpy change is the amount of heat taken in or given out at constant pressure during any physical or chemical change. The standard enthalpy change for a reaction is the change in enthalpy when reactants in their standard states form products that are also in their standard states. The standard state of a substance at a given temperature is its pure, most stable form at 100 kilopascals. A standard enthalpy of formation is the enthalpy change under standard conditions when 1 mole of a compound is formed from its elements with all reactants and products in their standard states. The standard enthalpy of combustion is defined as the enthalpy change under standard conditions when 1 mole of a substance is burned completely in oxygen with all reactants and products in their standard states. The first law of thermodynamics states that the energy can neither be created or destroyed but is merely converted from one form to another. And Hess's law states that the enthalpy change of a reaction depends only on the initial and final states of the reaction and is independent of the route by which the reaction occurs. The ionisation enthalpy is the standard enthalpy change for the removal of an electron from a species in the gas phase to form a positive ion and an electron, both also in gas phase. The enthalpy of atomisation is the standard enthalpy change that accompanies the formation of 1 mole of gaseous atoms from the element in its standard state. The bond dissociation enthalpy is the enthalpy change that accompanies the breaking of a covalent bond in a gaseous molecule to form 2 gaseous free radicals. A free radical is a species that results from the homolytic fission of a covalent bond. It contains an unpaired electron, and since homolytic fission results in the splitting of the electron pair in the covalent bond, 1 electron goes to each of these radicals. The electron affinity is the standard enthalpy change when an electron is added to an isolated atom in the gas phase. The enthalpy of lattice dissociation is the standard enthalpy change that accompanies the separation of 1 mole of an ionic lattice into gaseous ions. The enthalpy of lattice formation is the converse of this, the standard enthalpy change that accompanies the formation of 1 mole of a solid ionic lattice from its gaseous ions. The enthalpy of hydration is the standard enthalpy change for changing 1 mole of gaseous ions into 1 mole of aqueous ions by dissolving in water. The enthalpy of solution is the standard enthalpy change that occurs when 1 mole of an ionic solid dissolves in enough water to ensure that the dissolved ions are well separated and do not interact with each other. The mean bond enthalpy is the average of several values of the bond dissociation enthalpy for a given type of bond and is taken from a range of different compounds. A spontaneous change is one that has a natural tendency to occur without being driven by external influences. An amphoteric oxide is one which is capable of reacting both with acids and bases. Oxidation is loss of electrons, reduction is gain of electrons, and the standard EMF, or electromotive force, is the potential difference between the electrodes of a standard electrochemical cell measured under zero current conditions, and the electrode potential of the standard hydrogen cell is always zero. A primary cell is irreversible and is not intended to be recharged by an electric current, for example the batteries in your remote control at home. A secondary cell is reversible and is specifically designed to be recharged by an electric current. This could be a rechargeable phone battery or a rechargeable normal battery that you use in everyday things. For example, you can actually get batteries that are rechargeable that go in your remote, like AA and AAA batteries. A fuel cell generates electricity from the continuous oxidation of an external fuel source and is an open system. A transition element is an element having incomplete D or F sublevels in either its element or one of its common ions. A ligand is any atom, ion or molecule which can donate a lone pair of electrons to a metal centre. The number of bonds to a metal ion is called the coordination number. A catalyst which acts in a different phase from the reactants is called heterogeneous. A catalyst which acts in the same phase as the reactants is called homogeneous. A Lewis acid is an electron pair acceptor, and a Lewis base is an electron pair donor.